All right, perfect. You can go ahead.
All right. Thank you everyone for attending my talk. Today I'm going to explain you how we can generate performant, readable, and interoperable Rust from Dafny. My name is Mikael Meyer. I work at Amazon Web Service, and this is joint work with Siva, John, Shadaj, and Fabio. So in English, we have an expression that says, let's address the elephant in the room. As you know, Dafny until now has been mostly compiled to garbage collected languages, and which is symbolized here with the trucks full of plates going to a recycling factory. And the rest is not garbage collected. So how would we address this problem? And this is the first problem I was thinking about when I was giving the task of taking over this Dafny'25 compilers that John and Shadaj had worked on before me. And we'll go back to this later. But first, the first question is why would you even care compiling Dafny to Rust? And I will assume that you are this person in a deep committed relationship with Dafny and you love writing proof. You sometimes wish it was a bit easier and less brittle, but overall it's a good experience. And now you want to publish a Rust library from your Dafny code. And so this is the case for one of our clients at Amazon. As Ruslan mentioned it earlier, the encryption SDK now compiles to several programming languages, and it's not a coincidence if all these programming languages are the one that Dafny support as backends. And if you see, if just this week they released a new Go library based on the Dafny2Go compiler. So it makes sense that they would want to expose their encryption SDK for Rust, right? So for the story, I developed the compiler for a few months, and then Fabio and Siva joined me at the end, so that we were able to publish a compiler for Rust from Dafny'25 mid-July last year. So that was a great success experience. Along the way, we gathered a few needs for this compiler because it was based on a novel architecture with an intermediate representation that project mentioned earlier. Oh, sorry, Daniel mentioned earlier. And about this, the final output, we wanted the output to be readable so that we could debug it and it would be easier to trust. We wanted also the code to be correct and compiled in a way that can be run extremely efficiently, if possible, because this is what Dafny was meant for. And last, we want to be able to import and export Rust definitions so that the API of our libraries are not kind of weird, they're actually quite readable. And what we wanted was based on what we gathered from our users. So let me first show you a few challenges we faced. Can we improve local names? For example, in Dafny, let's say we have a Dafny program with 11 holidays. We have days off, which is the same number as holidays. And if you're lucky, you get 2 extra holidays and you reassign the holidays to day off. And here you see in the blue, we are overriding a variable with the same variable name. So in every other backend, what you will see is you have 2 variables for these 2 holidays, which are homonymous, which are prefixed with underscore, number, underscore, and they have different numbers so that we identify them uniquely. And it's necessary because we declare variables before assigning them. But in the Rust compiler, we worked on so that we could actually reuse the same variable names and get rid of all this, most of the underscore, number, underscore, so that I think at the end, the Rust generated code is much more readable. And we can do this because we have a novel architecture in which you can even do some post-processing to gather assignments and declarations. Another readability aspect is, can we keep single underscores? Let me explain you the issue. Let's say we have a function, how many dogs can you have? Depends on whether you have a cat, which is a Boolean, another cat, prime, which is a Boolean, and whether you have a yard, well, that ends with a question mark. And if you see, the first 2 identifiers are perfectly valid characters for most programming languages, but Dafny identifiers can have apostrophes and question mark. And obviously, this doesn't fit well into our backend. So what we do for every other backend is we double the underscores, and that way we can use underscores as an escape character to encode the apostrophe and the question mark, which means the identifiers are not the same when they have underscores. So in Rust, we made it so that we can reuse the same names if they are underscores, and if they are special characters, we prefix identifiers with underscore and apply the escaping transformation. And you might think, well, hey, will that actually collide in some ways? Will we have any problems? And the good news is, since the pipeline is written in Dafny itself, the last part of this pipeline, we actually have a lemma that proves the mapping to be injective. And this is in our CI, continuous integration, so it will always remain valid as long as no one touches this proof. So we have more readable identifiers. Now, can we have relative path? Is something that's almost in every other backend. Let me show you what happens. In Dafny, let's say you have a module living room, and you define a present as either being a toy with an index or a box with a present. And if you import to the living room, and you have a method main, you can have you say, okay, in my method main, I have a present, which is a box or a toy of one. Very concise program. So in almost every other backend, we always mention the living room module. And the reason is it's very hard to import something and make sure there is no ambiguity. So because in Rust, we have control of over the final generated tree, we can actually have a post-processing phase which will read the entire tree and factor out this absolute path into import statements. And that's why we can have shorter types overall. And this is very interesting because it resulted in a 20% code reduction in the encryption SDK. So for readability, it was a huge improvement. There are many more readability improvements, but I would like to move on now to the other aspect that I talked at the beginning, how to manage references. And let's go back to our garbage collection. The story was as follows. I was tasked to implement a garbage collector so that we could actually enjoy garbage collection within Rust itself. I did implement one myself. It was not an easy task. And then I realized for maintenance, it would be better to use an external library. There were two garbage collection libraries in Rust at the time. One was not maintained, and the other one would require to keep track of the path from the root level of every reference. So the code will not be readable, maintainable, everything you don't want. So then I realized something very interesting is that Dafny is not assuming garbage collection. Dafny actually assumes, if it assumed anything, that objects live forever. Because you could always assert some properties about an object which was a long time ago garbage collected, and still the assertion will still hold. So this led me to thinking perhaps we should do one thing that I wanted to experiment with. We should just have a row pointers and have a way to manually delocate references if we have a good theory of that, which is kind of washing dishes yourself. And the crypto tools, the team is responsible for the encryption and SDK wanted something more like a reference counting, so that at least the cleaning will be done automatically. They would not have to add this free statement. And so I also thought we should do mutable reference counting for them, which in some cases could have some deadlocks, but for them it will not be the case. So how to encode mutable references? So in Dafny, you have this class York, and you have a new label variable X that is an instance of York. And in Rust, you have a struct of the York, but struct in Rust are just a collection of bytes. So if you wanted to have a pointer, it should be behind a kind of wrapper around your structure, and this wrapper should indicate that it's nullable, reference counted, and mutable. So the reference counted part is called RC, the mutable one is called refcell in Rust, and the York. And here's how it's laid out in memory. It's very interesting. So in memory, if you look at the heap, what the pointer points to, it's a strong count, a weak count, then a borrow flag, and then the actual data of the York class. So since we don't have any runtime borrow checks, we can just replace refcell by unsafe cell, and it works the same. And with the variant with the row pointers, we can actually use non-null instead of RC. We get rid of the strong count and weak count. Now we have the nullability. of this pointer, which is done in a very clever style in Rust, because it knows that non-null and RC are not null pointers, so it can encode the 0 as a non-variant of the option type, and that this is a zero-cost abstraction. There are one more zero-cost abstraction that we need is a wrapping with a new type, so that we can fine control the equality, because equality of object has to be based on pointer addresses and not pointer addresses and virtual dispatch addresses like it is done in Rust. So once we did that, we can have pointers that match the semantics of Dafny pointers. So now we have a reference, we have a covariance. In Dafny, it's possible to have covariance. Let's say you have a holiday, and you have a class MLK that extends holiday, and your data type option with our covariant type parameters. And now you want to test something. You do something crazy. You put an instance of MLK into a sequence, into an option, into a sum, and then you convert it to an option of sequence of holiday, because MLK is a holiday. This is possible in Dafny. Rust doesn't allow you to do this normally, because simply the traits have 16 bytes with a virtual table, whereas the classes will only have 8 bytes for the data. So if you really want to do this, we emit coercion combinators that you can use to convert all your data, your types to the types with the traits. But I would advise against it. If you can avoid it, use bound type parameters and try to upcast only at the last moment. So there are also initialization tracking bits. So let's say you want to make a step where you are alive or not, you are eating or not. It requires that if you are eating, you must be alive. And let's say we want to measure the luck, which is an intermediate variable. If you are alive, you define luck to 1. If you're eating, you define luck to be equal to luck plus 1. And this is a bit tricky in Rust, because in Rust, it assumes that every local variable will be collected at the end of the scope. But the problem is, if it doesn't know whether it's initialized or not, it will emit an error that we have to resolve, because it will not be able to determine it. So if you look at the generated Rust code, we need to assign luck a value, which we put as a placebo value, so it's a kind of option type. And with this one, Rust is satisfied, we not emit warning, but you can see that the readability of the code is really affected. So to avoid this initialization tracking bit, we implemented an abstract interpretation over the Dafny intermediate representation. And if you rewrite the program in a way that if you not alive, you return, and if you have food, you assign luck. So in every pass, you know whether luck was initialized or not. And in the step on the right-hand side, you see that our search interpretation engine figures out that the variable luck can be assigned the type Dafny int, which will be collected or not, and Rust can figure out this out by itself. So Dafny also supports external instance methods. Let's say you have a coin flip that returns a Boolean, but you define it as extern. And now you have a coin flip int that will convert this Boolean to integer. Though you can run this command line, and now you have something interesting that happens is the external method doesn't appear. Excuse me. Yep, something's wrong with my slide. Yes. The external method doesn't appear, but it is being called. So you can actually implement in an external file, and Rust makes it very easy to implement external methods on types in other files. So you can support external instance methods quite easily. The same way you can support external types, although it's a bit more complicated. If you have a time in a time container and you want a get method, you will see that in generated code, it will import all the types from an external module, which will import all the types from an external file. This means that in your external Rust file, you can actually have the same module name, same struct that you want to have, and define its own implementation there. As an evaluation, we converted many different projects to Rust, and we had up to 100% the speed of a handwritten Rust code. 15 readability features, which include 11 unique to the Dafny'25 compiler, and the encryption SDK has 28 external files. As a conclusion, the output is readable and debuggable. It can be made performant. It interprets well, and there is more to come. And you can try it out by yourself with the Dafny Translate or Dafny Build, Run, or Test on your files as of today. And if you want, we can continue discussion on Zulip chat. You can find me there or on this new Zulip chat channel. Thank you very much. Sure, if I hear questions. Will I hear questions here?
Any questions? No questions? Oh, there's one question.
So as
If there is no question, I'd be happy to answer one myself. But go ahead.
So as Rustan alluded to this morning, we had a lot of success using linearity at least.
I had a lot of success using what exactly? Can you repeat?
Sorry, using linearity at the source level to simplify proofs in one way or the other.
Yes.
Since Dafny doesn't have that, do you run into places where it's awkward to satisfy the Rust linearity checker?
No, that's an excellent question, actually. And no, we don't run into that because we only compile to types that are clonable. And every time we need, we clone the variables, we clone the values. So we don't run into this linearity issue. But at the same time, we want to benefit from it. And we have plans to add some annotation or attributes so that you could represent types in our own way. And if you overwrite a variable with itself modified, you could actually compile this to an in-place modification in the compilation pipeline. Yes, we can do this.
Cool, thank you.
Welcome.
Let's thank the speaker again.
Thank you very much.